Let's start with the big idea itself. What if we just started throwing all of our trash into volcanoes? It sounds like something out of a cartoon or a wild science fiction movie, but it's a question people have seriously asked. On the surface, it kind of makes sense. Volcanoes are basically giant natural furnaces. When they erupt, they release heat that can reach over 2,000 degrees Fahrenheit. That's hot enough to melt rock, so it feels like they could definitely melt some of our everyday waste, right? The world has a massive trash problem. Every single year, we produce more than 2 billion tons of solid waste. A lot of that ends up in landfills, where it just sits and slowly breaks down. If it ever breaks down at all, some of it ends up in our rivers and oceans, harming wildlife and poisoning water. So the idea of a super hot volcano burning it all away might sound like a perfect solution. Just dump the trash in and let nature take care of the rest. But even before we get into the risks or the science, there are some obvious challenges. First, volcanoes aren't everywhere. In fact, most of them are located in remote or dangerous places. The idea of loading up trucks or planes full of garbage and hauling them across the country or even across the world to reach an active volcano is already a logistical nightmare, not to mention the cost and the pollution caused by moving all that trash in the first place. Then there's the problem of getting close enough to a volcano. Active volcanoes aren't exactly stable or safe. Just being near one, even when it's not erupting, comes with risks like toxic gas, sudden lava flows, earthquakes, or landslides. Most waste disposal systems today are built to be safe and manageable. Trying to throw bags of garbage into a boiling pit of lava is neither of those things. Even if we could get the trash there, how do we actually get it in? Just tossing it from a distance wouldn't work, and getting close enough could be deadly. And here's another thing to consider. Not all volcanoes are the same. Some have open lava lakes like the ones in Hawaii, but those are rare. Most volcanoes only have visible lava during or right before an eruption. So even if we picked the right volcano, there's a good chance we'd be sitting around waiting for the lava to show up. And trying to time our garbage drop with an eruption would be dangerous and probably impossible to control. So before we even touch on the science of whether or not it would work, the basic logistics already show some pretty serious roadblocks. It's an idea that gets attention because it sounds extreme and powerful, but just getting the trash to the volcano and getting it in would be an expensive, dangerous, and very unpredictable process. In the next part, we'll look more closely at what would actually happen to our trash in a volcano and whether it would even burn the way people think. Now let's imagine that somehow we did manage to get all our trash to an active volcano and safely dumped it into the lava. What would actually happen to it? Would it just melt away instantly and disappear? The answer isn't as simple as you might think. When something falls into lava, it doesn't always burn up right away. Lava is extremely hot, usually somewhere between 1,300 and 2,200 degrees Fahrenheit, but it's also thick and dense. It flows more like syrup than water. That means solid objects like metal, plastic, or large bags of trash might just sit on top of it for a while instead of sinking or melting immediately. Some items would catch fire, sure, but others might not even fully break down. Another thing to think about is what happens to the smoke and gases released when trash burns. A lot of everyday items, especially plastics and electronics, release toxic fumes when they're set on fire. These include chemicals like dioxins, furans, and heavy metals, which are dangerous to both the environment and human health. If we started burning tons of garbage in volcanoes, we'd be pumping even more pollution into the air, except now it would be coming out of a volcanic crater. Scientists have studied volcanic gases and found that they already release carbon dioxide, sulfur dioxide, and other harmful substances during eruptions. Adding household or industrial waste into that mix could make it even worse. It could affect air quality for miles around, especially for people living near the volcano. And unlike a controlled waste incineration plant, volcanoes have no filters or scrubbers to catch the bad stuff. Everything just goes straight into the sky. There's also the question of whether all trash would even break down under those conditions. Materials like glass and certain metals require extremely high temperatures to melt. Some parts might survive the heat or only partially melt, leaving chunks of waste behind in the lava or on the volcano's surface. And that's not even counting hazardous waste, which could react unpredictably under those extreme temperatures. And then there's the simple fact that volcanoes don't erupt on command. Lava isn't always available, so unless we're lucky enough to have an open lava lake, we'd be stuck with huge piles of trash waiting for the next eruption. That could take years or even centuries. In some places, a volcano might stay quiet for hundreds of years before it erupts again. So while the heat of a volcano sounds powerful enough to destroy anything, the reality is messier. Some of the trash might burn. Some might just sit there. Some could release dangerous chemicals, and some might never melt at all. In the next part, we'll look at places where this idea has actually been studied in the real world, and what scientists found when they tried to explore it. Even though tossing trash into volcanoes sounds wild, this idea has actually been looked at in a few places around the world, not just as a fantasy, but as a serious research topic. One of the most well-known cases is in Iceland, where scientists have studied how geothermal and volcanic energy might be used to manage waste. Instead of throwing trash straight into lava, they explored ways to use the natural heat from underground volcanic systems to help break down waste in a more controlled setting. In Iceland, some research teams looked into using geothermal vents, those super hot steam pockets underground, to process organic waste like food scraps and plant material. The idea was to create a waste-to-energy system by capturing the heat and turning it into electricity, or using it directly to decompose certain types of waste. It wasn't about dumping garbage into volcanoes, but more about working with volcanic heat in a smarter and safer way. Other volcanic regions like Hawaii and parts of Italy have also looked at similar concepts, but none of these ideas involve actually feeding trash into open craters. It turns out the dangers and unknowns are just too high. For example, one concern is what happens if foreign materials like plastic or metal interact with molten rock. These things could cause unpredictable chemical reactions, including explosions, especially if certain gases are released. There's also the question of logistics. Most of the world's waste isn't produced anywhere near volcanoes. Cities like New York, Tokyo, or London produce thousands of tons of garbage every single day, but they're nowhere near active volcanoes. That means we'd have to ship massive amounts of waste across oceans or borders just to reach a volcano. And that's not only expensive, but also terrible for the environment. Transporting trash by boat or plane releases more greenhouse gases, which defeats the whole point of trying to clean things up in the first place. In addition to the cost and environmental impact, there are safety concerns too. Volcanoes are unpredictable. Some may look calm for years, then suddenly erupt without warning. The idea of setting up a waste disposal system around something so unstable doesn't exactly sound like a smart move. And even if we found a constantly active lava lake, we'd need to build roads, containers, and equipment to dump the trash without putting workers or nearby communities in danger. There's also the question of how locals and governments would feel about turning a natural wonder into a giant trash pit. Volcanoes are often sacred in certain cultures or protected as part of national parks. Turning them into dump sites wouldn't just be dangerous, it could also spark huge social and political backlash. So while the science of using volcanic heat in a safe, controlled way might hold promise, the idea of straight up tossing garbage into active lava is way more complicated. In the final part, we'll break down what we've learned and talk about what this idea really says about our struggle with trash and how we think about solutions. Now that we've looked at the science, logistics, and real-world attempts, it's pretty clear that throwing our trash into volcanoes isn't the magic fix it might seem like at first. Still, the fact that this idea even comes up shows just how desperate people are to find new ways to handle the massive amount of waste we create every single day. What this concept really highlights is how we keep looking for big, dramatic solutions instead of dealing with the root of the problem, how much we produce and how little we reuse. Even if volcanoes could somehow burn up all our garbage, it wouldn't stop the constant stream of new waste being created. Plastic packaging, food waste, electronics, it's all still being made faster than we can deal with it. That's a deeper issue that volcanoes can't solve, and while using extreme heat from volcanoes sounds powerful, it doesn't erase the risks. Burning waste, no matter where it happens, can still release harmful gases into the air. If we're talking about plastics, chemicals, or electronics, the fumes and byproducts can be dangerous to both people and the planet. It's not just about getting rid of garbage, it's about what happens to that garbage when we do. There's also something symbolic about wanting to throw our waste into a volcano. It's like we're trying to bury the problem instead of facing it. Just dumping it out of sight doesn't make it go away. In fact, it often creates new problems, whether it's toxic emissions, transportation pollution, or environmental damage. Instead of trying to destroy our waste in the most extreme way possible, a more practical path might be reducing how much we create in the first place. Recycling, composting, reusing materials. These methods may not be flashy, but they work. And unlike volcanoes, they don't carry the risk of explosions, lava burns, or air contamination. So, while the idea of using volcanoes as giant trash incinerators might sound exciting, it's not a real solution. It's more of a reminder that we need to think smarter about how we live, what we consume, and how we take care of the earth. We already have the tools to make a difference. It just takes the will to use them. Thanks for sticking with this crazy idea. Let us know what wild solutions you've thought about when it comes to the trash problem. Weather control has been a dream and a mystery for humans for a very long time. Imagine being able to make it rain when crops need water, or stopping a big storm before it causes damage. It sounds like something out of a sci-fi movie, but with how fast technology is growing, it's not crazy to think we might actually get there someday. If humans learned how to control the weather, it could change everything about how we live on this planet. For farmers, it could mean ending droughts by bringing rain exactly when it's needed, helping grow more food and feeding more people. For cities, it could mean less damage from hurricanes or floods because storms could be weakened or redirected. This kind of power could help protect lives and save money, but weather is not simple. It's made up of many parts working together: air, oceans, temperature, wind, and even the sun. All these things interact in ways we don't fully understand yet. So controlling the weather wouldn't be like flipping a switch. It would be more like trying to solve a giant puzzle where every piece affects the others. This means any change we make could cause effects far away or far in the future that we didn't expect. One big question is what exactly would happen if we started changing the weather on purpose. For example, if we caused rain to fall in one place, would another place lose its rain? Would making it sunny in one area cause a drought somewhere else? The Earth's climate system is connected across the whole globe, so messing with one part could cause big problems somewhere else. And then there's the danger of overusing this power. If humans got used to controlling the weather, they might start changing it for small reasons, like always having clear skies for outdoor events or cool temperatures on hot days. But every change in nature has a balance, and breaking that balance could lead to serious problems. For example, if we stop storms too much, it could stop important natural cycles that keep our environment healthy. So while the idea of controlling the weather sounds amazing, it's also scary to think about the possible dangers. It's a huge responsibility, and we would have to be very careful not to cause more harm than good. In the next part, we'll look at some ways scientists are already trying to influence the weather and what problems those efforts have faced. Even though fully controlling the weather is still a long way off, scientists have been experimenting with ways to influence it for decades. One of the oldest and most well-known methods is called cloud seeding. This technique tries to encourage rain or snow by adding tiny particles like silver iodide or dry ice into clouds. These particles help water droplets inside the clouds stick together and fall as precipitation. Cloud seeding has been used in different parts of the world since the mid-20th century. For example, during the drought in California in the 1970s, efforts were made to increase rainfall by cloud seeding. Some places have also tried it to reduce hail that can damage crops or buildings. While some reports say it helped, the results are mixed, and scientists still debate how effective it really is. Beyond cloud seeding, there are even bigger ideas called geoengineering projects. These involve changing the Earth's climate on a large scale to try and fix problems like global warming. One idea is to spray tiny particles high into the atmosphere to reflect some sunlight back into space, which could cool the planet a bit. This is sometimes called solar radiation management, but geoengineering brings up a lot of concerns. First, it's unclear what side effects could happen. Changing the amount of sunlight reaching Earth might cool some places, but cause droughts or floods in others. Also, if we relied on this to fight climate change, it might stop people from reducing pollution and greenhouse gases, which are the real cause of the problem. Another issue is who gets to decide when and how to use these technologies. Weather and climate affect the whole world. So if one country tries something and it causes problems in another, there could be serious conflicts. Imagine if a country caused rain to fall on its own farmland, but ended up causing droughts in a neighboring country. This could lead to political disputes or even fights. Scientists are also exploring new technologies that might improve how well we can predict the weather. Better forecasts could help us prepare for storms and avoid disasters without actually changing the weather itself. Using satellites, powerful computers, and better weather models, meteorologists are getting more accurate at knowing when and where extreme weather will happen. So, while cloud seeding and geoengineering show us some ways to influence the weather, they also teach us how tricky and risky this can be. The Earth's systems are delicate, and even small changes might create big problems we don't see coming. In the next part, we'll explore what could go wrong if weather control gets into the wrong hands, and what scary consequences might happen if things are pushed too far. One of the biggest worries about humans controlling the weather is what could happen if the technology falls into the wrong hands or is used without careful thought. Imagine if powerful weather control tools became weapons. Countries or groups might try to create storms, droughts, or floods to harm enemies or gain an advantage. This idea sounds like something from a thriller movie, but it's a real concern among scientists and governments. Weather warfare isn't new as a concept. In the 1960s, during the Vietnam War, the US military tried to use weather modification to extend the monsoon season, hoping to disrupt enemy supply routes. They used cloud seeding to cause heavy rains, but the full effects and consequences of those actions are still debated today. This shows how controlling weather, even on a small scale, can be unpredictable and controversial. Another scary possibility is that controlling the weather might create new kinds of natural disasters. Because weather systems are so complicated, changing one thing could trigger others. For example, if we tried to prevent hurricanes by cooling ocean temperatures in one area, it might cause stronger storms somewhere else. Or stopping rain in one place could lead to deadly droughts and wildfires. Also, weather control might hurt natural ecosystems that depend on certain weather patterns. Many plants and animals have adapted over thousands of years to the local climate. Sudden or artificial changes could disrupt migration patterns, breeding seasons, and food availability. This could lead to loss of biodiversity and damage to the environment that might be hard or impossible to fix. There's also the chance that people could become too dependent on weather control technology. If we start relying on machines to fix everything, we might forget how to prepare for natural events or adapt to changing conditions. And if the technology breaks down or stops working for some reason, the sudden return to natural weather patterns could cause chaos and confusion. These risks show that controlling the weather isn't just about technology, it's also about ethics, responsibility, and global cooperation. Who decides when to change the weather? How do we make sure it's done fairly and safely? These questions don't have easy answers, but they are important to think about as we move closer to making weather control a reality. In the next part, we'll look at some of the exciting scientific progress being made today and what the future might really look like if humans do gain control over the weather. Despite all the risks and challenges, scientists and researchers are still pushing forward with new ideas and technologies that could help us better understand and maybe even control the weather one day. One area showing promise is improving how we predict weather events. With better data from satellites and supercomputers, weather forecasts are becoming more accurate and can warn us earlier about storms, heat waves, or heavy rainfall. This means we can prepare better and reduce damage even if we're not fully controlling the weather yet. There are also exciting experiments with new materials that might help with weather modification. For example, some scientists are studying how tiny particles could help clouds produce rain more reliably, or how smart drones could spread these particles more precisely. These efforts aim to make cloud seeding more effective and less harmful to the environment. Another interesting idea is using nature itself to help control local weather. Planting more forests or restoring wetlands can change how moisture moves through the air and help regulate temperature. These natural methods might not be as fast or flashy as machines, but they work with the environment rather than against it, making them safer in the long run. Looking ahead, the future of weather control will likely be a mix of technology and nature, combined with careful rules and global cooperation. Scientists warn that we have to move slowly and think carefully about every step, because once we start changing the weather on a big scale, it will be hard to undo. So, what would really happen if humans learn to control the weather? It could bring amazing benefits like ending droughts, protecting communities from storms, and helping farmers grow food better. But it could also lead to new dangers, conflicts, and damage to the environment if not handled responsibly. At the end of the day, weather control is one of those powerful tools that could change the world for better or worse. The future depends on how wisely we use it, how well we understand nature's delicate balance, and how much we work together as a global community. What do you think? Would you trust humans with the power to control the weather, or does it sound too risky? Drop your thoughts in the comments, and if you're curious about more cool science topics and ideas about the future, be sure to check out my other videos. Icebergs are huge pieces of freshwater ice that break off from glaciers or ice shelves and float in open water. Most icebergs form in places like Antarctica and Greenland, where massive sheets of ice stretch out into the sea. When a chunk of this ice breaks away, it becomes an iceberg. This process is called calving, and it happens naturally as the edge of a glacier moves forward and becomes unstable. And once in the ocean, icebergs start drifting. Their movement is mainly controlled by ocean currents, winds, and tides. These forces push icebergs away from their origin and can carry them hundreds or even thousands of miles. Some icebergs stay far out in the ocean and slowly melt away over time, but others take a different path. They move into shallower coastal waters, getting closer and closer to land. Not all icebergs make it that far. Many break apart or melt before reaching the coast, but the larger ones, some as tall as buildings and as wide as city blocks, can last for months or even years. These giants can eventually run into underwater ridges or shorelines. When this happens, the collision can be intense, especially if the iceberg is still mostly intact and moving with speed. The chance of an iceberg hitting land depends on where it forms and the currents it follows. Along the coasts of Canada, Greenland, and parts of Antarctica, iceberg landings are more common. In some areas, people keep a close watch on iceberg movements to avoid accidents, especially where shipping routes are nearby. When an iceberg finally reaches land, the result can be dramatic. These frozen masses, some weighing millions of tons, move slowly but with enormous force. Even at a few knots of speed, the sheer size and weight of an iceberg can cause serious impact when it meets solid ground. The collision usually starts beneath the surface, where most of the iceberg's mass is hidden underwater. Nearly 90% of an iceberg sits below the waterline, so the contact with the seabed or coastal terrain begins before anything is seen above. As the underwater base scrapes or slams into the shore or a submerged slope, the iceberg can grind to a halt. This creates a loud, deep rumbling that sometimes feels like a small earthquake. The pressure can tear away chunks of the seabed, disturb marine ecosystems, and stir up sediment that has been resting for centuries. In shallower waters, this process can even reshape parts of the coastline. Above water, the collision can cause ice to break off in large chunks. Pieces the size of trucks or houses may split and fall into the sea. This often triggers sudden waves, which can be dangerous for nearby boats or structures. In remote regions like Greenland or the Antarctic coast, these waves might go unnoticed, but in areas closer to human activity, the surges can damage docks, fishing equipment, or even buildings near the shoreline. In some cases, if the front of the iceberg is pushed upward against land, it may tilt or roll. This can create even larger waves and send ice debris flying. While rare, these rollovers are powerful and can pose a threat to ships or coastal stations monitoring ice movement. Once an iceberg is grounded, it may stay lodged in place for weeks or even months, slowly melting or breaking apart as weather conditions change. Once an iceberg has collided with land and come to a stop, the environmental changes begin to unfold over time. One of the most noticeable long-term effects is coastal erosion. As the iceberg melts, the runoff from fresh water can destabilize nearby soil and rock, slowly wearing away the land. In areas with permafrost or fragile coastal shelves, this can lead to landslides or cliff collapses over weeks or months. Another effect is the sudden change in salinity in the surrounding ocean water. Icebergs are made of fresh water, and as they melt, they release huge volumes into the saltwater environment. This can upset the balance of local marine ecosystems. Species that rely on stable salinity levels may be forced to migrate, while others might not survive the shift. In places like the North Atlantic and around Antarctica, these disruptions have been linked to changes in fish populations and plankton growth. The release of sediments is another concern. When an iceberg scrapes along the ocean floor before hitting land, it stirs up mud, sand, and ancient debris buried beneath. As the iceberg rests and melts, this material can be deposited along the shoreline, altering habitats and sometimes burying smaller ecosystems. In some regions, this process has even reshaped tidal zones and shallow bays. There's also a chain reaction in the local food web. As certain fish or crustaceans move away due to habitat loss or water changes, animals that feed on them like seabirds or seals may begin to struggle. These ripple effects can last for years, depending on the size of the iceberg and the sensitivity of the environment it impacts. Finally, iceberg collisions can influence local climate patterns. Large icebergs absorb and reflect sunlight differently than open ocean or land. When grounded near a coast, they can slightly cool the nearby area. This can delay seasonal ice melt or shift wind and weather conditions along that coast. Over the past century, there have been several recorded cases of icebergs colliding with land, especially in polar regions and remote coastal zones. One notable example occurred in the early 20th century when a large tabular iceberg broke off from Antarctica and grounded near South Georgia Island. The massive chunk of ice disrupted local wildlife, blocked ship routes, and took years to fully melt away. Events like this have helped researchers understand just how disruptive iceberg groundings can be. In recent years, the iceberg known as A68, which calved from Antarctica in 2017, gained global attention as it drifted dangerously close to South Georgia Island in 2020. Although it narrowly avoided direct landfall, its approach alone stirred international concern due to the threat it posed to fragile ecosystems and global shipping lanes. Today, scientists use satellite tracking, radar, and ocean buoys to keep a close eye on iceberg movement. Organizations like the U.S. National Ice Center and the European Space Agency monitor large icebergs in real time. These systems help predict where an iceberg might go, how fast it's moving, and whether it's likely to hit land. This kind of information is vital for researchers, coastal planners, and even fishing operations in the Arctic and Antarctic regions. Scientists also study the structure and thickness of icebergs to understand how they'll behave if they reach shallow waters or make landfall. Icebergs that have been weakened by warmer ocean currents tend to break apart more easily, reducing the chance of a dramatic impact. But with rising global temperatures, more frequent and unpredictable iceberg calving events could increase the chances of land collisions in the future. Looking ahead, climate change could make these collisions more common. As polar ice sheets continue to melt, more large icebergs are breaking away and entering shipping routes or drifting toward populated coastlines. While most melt harmlessly at sea, a small number still make contact with land, especially in places like Greenland, parts of Canada, and the southern Atlantic islands. Ultimately, iceberg collisions with land are rare but powerful events. Through technology and ongoing research, scientists hope to stay ahead of these natural forces and minimize their potential impact on both human activity and the environment.